Okay, now section 6.5, average value of a function. Okay, in this section, we're going to run the mean value theorem for integral. Okay, average value of a finite many numbers, y1, y2, yn, is defined as divide the summation of the ni's by n. So we call that the y average. Okay, y average can be found in this way. To compute the average value of a function, y is equal to f of x. Okay, this is the way that we do. Okay, divide the interval into n equal subintervals with the length of delta x, which is n b minus a over n, and take point xi stars in successive intervals, and then calculate the average of the numbers f of x1 star fn star. Here, the point x1 star to the xn star, and f of x1 star f of n and f of xn stars. Okay, since delta x is this, so n can be written as b minus a over delta x. So the average value becomes this, which can be written in this way. If we send n to infinity, then the limiting value, this one, can be written in this way. So here is the limit, and summation gives us the integral. So this value can be found as the 1 over b minus a times the integral from a to b f of x dx. We call this value is the average value of f on the interval ab. So like this. So we write f average as this. Let's find the average of average value of this function f of x plus x squared on the interval minus 2 to 1. Then a is minus 2, b is 1, and f of x this. So 1 over b minus a times the integral a to b f of x dx can be written in this way. So we do just simple integration to have 1/2 as the answer. Okay, from here we can draw the following theorem. Okay, which gives us a number c, at which the value of f is exactly equal to the average value of the function, which is this. F of c is equal to f average, like this. This is called the mean value theorem for integral. If f is continuous on the interval ab, then there exists a number c in the interval such that integral a to b f of x dx is f of c times b minus c. So geometric interpretation of this theorem is for positive function f, there exists a number c such that the area of the rectangle with the base AB, the height f of c, is same as the area of the region under the graph of f from a to b. As you see here, the integral, the area of this is same as the product of this the height and the width. And that there exists this height f of c, or you can see like this. Here, like if you have an integral, if you're looking for the integral like this, then the area of this is same as this base times this height. There exists a c, which is all about 0.2. That this area is same as this area. And here, this area was obtained by the integrating this function from 0 to 2, and this area was obtained by just multiplied the width and height. They are same. There exists a certain number and 0.2, like the c, that makes these are same. This is guaranteed by the mean value theorem for integrals. This is what it says. Example 2. Verify the mean value theorem for integral for this function, f of x equal to x plus x squared on this interval. Okay. Okay, we find the integral. Find the area. Okay. Okay, this is continuous, and by the, okay, by the mean value theorem for the integral, yeah, we know there exists a certain number c. Then how we can find it? Okay, we can just find the integral, and then divide by 1 minus 2. So what we have is f of c is equal to 1/2. That means c plus c square is equal to 1/2. So c square plus c is equal to 1/2. Solve this quadratic equation, which gives us this. So for the c values, 1/2 times minus 1 plus minus square root 3, and this f of c1 and f of c2 has the same value of f average, which is 1/2. So this we can verify the theorem by finding the exact value of c in there. And this the example 2 shows it. Yeah, the integral. This integral can be found by this f average can be found. You can find the c, yeah, and we can find the average, f average in here. Okay. Anyway, this figure 2 shows, what is the f average, and also those value can be found. The number c can be found in this interval to make it same with the f average. Okay. Last, average and instantaneous velocity here. For an object moving in a straight line with the position s of t at time t, the average velocity from time t to the time t plus h is the average rate of change of position with respect to time. So v average is the delta s over delta t. This is the average velocity, so which is the average rate of change of position. And the instantaneous velocity at time t is v, which is ds over dt, the derivative of s with respect to t, which is the instantaneous velocity. Okay, there are two types of velocity we introduced. Okay, here is an example to find those. A car travels with the velocity v. It's equal to 40 plus 10, where t is time. Between time t is equal to 0 and t equal to 4, find the average velocity with respect to time. Okay, so v average can be average velocity with respect to time t. V average can be found as the integration of v from a to b, and the b minus a is 4 minus 0, so is times was 104 here. So this is the way of finding the average of this function v, which is the velocity. So since we have v of t is 40 plus 10, and it's been moved from 0 to 4, so b minus a is 4. So we have the v average is equal to 1/4 times integral from 0 to 4, 40 plus 10 dt. That's the mathematical formulation of this problem. Then we just do the simple integration to find the which is 18. But also for this problem, to find the average velocity. So this velocity was the linear, so we can just find the initial velocity and the terminal velocity, which is v4 and v0, and add them and divide by 2. Then it also gives us the average speed, average velocity, which is 18. So, yeah, there are both ways of finding it. But if we have the complicated the form of this velocity function, then we may have you have to use the one of these ways, depend on the given problems. Last problem. Example 4. Find the average value of the function on the given interval. Y is equal to sine square root 2 from 1 to 2. So, find the average value of the function. So, what is the average function? That's the integral of y dx from 0 to 2 times 1 over 2 minus 1. That's what we are looking for. So, we define a function f as of this, and the distance moved are 1. So we just integrate this function from 1 with respect to x from 1 to 2 and divide by this 2 minus 1. That printout gives us these answers. If we draw the graph, then the first this is the sine x, sine square root x here, and the integral value, the integral of this function from 1 to 2, this area can be found as this interval times this height with this c. So this is the V average that we were looking for, which this graph was simulated. And also verify the mean value theorem for f of x is equal to e to the minus x squared times sine x in an interval 0, 2. Here, I may copy this address to show you the simulation. Okay. So by the mean value theorem for integral, we have a number 0.21 in the interval 0, 2, such that integral from 0 to 2 e to the minus x squared sine x dx is equal to f of c times 2 minus 0, which is almost the same. We see in the following graph. Okay, here, as you see, here, this gives us 3 graphs. This is for the given function from 0 to 2. This is the graph of the given function, and this is the integral area that draws, and this is the area that we found, and this graph is the area that agrees with the method, which is same agree with it. And as you see, this C is about 0.2. It is the area, this area and this area is same as I mentioned. And I think those are the things. I think that's it. So there are some exercises like this. Find the average value of the function on the given interval. Then f average can be found in this way. And for this function, it's to find the average. It's just to do 1 over 4 minus 2 integral from 2 to 4 ln of x dx, which can be found in this way. And this address gives you how to find it. If you are looking for the average function of this on this interval, then all you have to do is just set up the formula and to use the integrals to find the average functions like this. Okay. If you find it, then you can find the C with the mean value theorem for the integrals. And most of the theorems are asking you to find the average value of the functions and some applications of it. So you may do it with the mathematical formulation of the given conditions. Then the computation is easy and simple, definite integrals. I think that's it. That's the end of chapter 6. Any questions?